students, welcome to the next video of derivative. In today's video we are going to see or we are going to discuss about derivative of inverse function. Now let's start with derivative of inverse function. So the following properties of inverse functions are frequently used while dealing with derivatives of inverse trigonometric functions. So sin inverse sin x, we know that sin inverse sin x is x. Okay, this is true for all trigonometric ratios. So cos inverse cos x will be x, tan inverse tan x will be x, so on. Then second property is sin of sin inverse x is also equal to x. Similarly, cos of cos inverse x is also equal to x. Tan of tan inverse x is also equal to x, so on. Okay. Third property says that sin inverse 1 upon x is same as cosec inverse x. Okay, we just flip this part. 1 upon x will be x. Similarly, cosec inverse, if it is cosec inverse 1 upon x, then we can write this as sin inverse x. Okay, vice versa. Sin inverse 1 upon x is cosec inverse x and cosec inverse 1 upon x will be sin inverse x. Same rule is applicable for cos inverse 1 upon x. Okay, cos inverse 1 upon x will be sec inverse x and sec inverse 1 upon x will be cos inverse x. Similarly, tan inverse 1 upon x will be cot inverse x and cot inverse 1 upon x will be tan inverse x. Okay. Then next property is sin inverse minus x. Sin inverse minus x will be minus sin inverse x. Cos inverse minus x will be pi minus cos inverse x. Tan inverse minus x will be minus tan inverse x. Okay. Then next is a very important property. If x is a greater than 0 and y is a greater than 0 and xy is less than 1, then tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy. And if xy is greater than 1, then tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy plus pi. Okay. And if x is greater than 0 and y is greater than 0, then tan inverse x minus tan inverse y, that is equal to tan inverse x minus y upon 1 plus xy. Okay. Now let us see some example based on this. So first example is find derivative if y is equal to cos inverse 2x square minus 1. Okay. Now class, in previous video we had seen the derivative of composite function, right? Now you can say that this cos inverse 2x square minus 1 is a composite function. Yeah, it is a composite function, but we cannot find the derivative of this composite function. Why? Because the first function is an inverse function, right? So what we are going to do? Yeah, we can apply in this particular sum we can apply the composite rule. So composite rule will be this cos inverse 2x square minus 1, right? This is a composite rule. Here functions are cos inverse x and 2x square minus 1. So first we have to find the derivative for cos inverse x. So that will be minus 1 upon root of x square minus 1, right? Then we have to find derivative for this. Here we have to use u minus v rule, right? So it is a very lengthy procedure. So what we are going to do? We are going to just substitute x. What I am going to substitute? I am going to substitute x as cos theta. Now you know that if x is equal to cos theta, that means cos inverse x will be a theta. Okay, from the definition of inverse trigonometric function. So theta is a cos inverse x, right? Now y will be cos inverse. See very carefully. Y will be cos inverse 2 cos square theta, right? In place of x I am substituting cos theta. So I will get 2 cos square theta minus 1. Okay, and this is nothing but a formula of cos 2 theta. So finally what I am getting? I am getting cos inverse cos 2 theta, right? And we know that cos inverse cos x, that is equal to x only. So cos inverse cos 2 theta, that is equal to 2 theta. Okay. Now theta is a cos inverse x, right? From this theta is cos inverse x. So y is equal to 2 cos inverse x. Now differentiate. So 2 is a constant. So 2 will come outside of derivative. Into derivative of cos inverse x is minus 1 upon under root of 1 minus x square. So that is equal to minus 2 upon under root of 1 minus x square. Okay. So this is the final answer. It is so simple if you know the formula of derivative. Now let us see the second example. Y is equal to tan inverse a plus x upon 1 minus ax. We have to find dy upon dx. Now y is given as tan inverse a plus x upon 1 minus ax, right? This is nothing but formula of tan inverse x plus tan inverse y, right? That is equal to tan inverse x plus y upon 1 minus xy, right? So this part is a right hand side of this formula. So we can write this as a tan inverse a plus tan inverse x. Okay. Now tan inverse a is a constant part plus tan inverse x. Now we are going to differentiate y with respect to x. So derivative of constant will be 0. Derivative of tan inverse x will be 1 upon 1 plus x square. So final answer is 1 upon 1 plus x square. Okay. See one more example. Here y is equal to e raised to 2 log tan inverse x to the base e. Okay. What is given? E raised to 2 log tan inverse x to the base e. Okay. Now can I write this as log tan inverse x square to the base e, right? E raised to this 2. This 2 is nothing but the index or power of tan inverse x, right? Since n log m, that is equal to log m raised to n, right? So I am writing this as log tan inverse x raised to 2. Now this base and this base is same. So finally what I am getting? I am getting this as only tan inverse x square. Only this part. Right? Clear? So I am getting y as tan inverse x square. Now differentiating with respect to x, first we have to apply x raised to n formula. So derivative of x raised to n is n x raised to n minus 1 into derivative of tan inverse x. Derivative of tan inverse x is 1 upon 1 plus x square. Okay. So this is the final answer. Now let's see the next sum. So find dy upon dx if y is equal to tan inverse 5x minus 4 upon 5 plus 4x, right? So first what I am going to do, I am going to divide numerator and denominator both by 5. If I divide, then what I will get? I will get numerator as x minus 4 upon 5 and denominator as 1 plus 4 upon 5x. Now this is exactly in the form of tan inverse A minus B, right? Tan inverse x minus y upon 1 plus xy. So that is equal to tan inverse x minus tan inverse y. So tan inverse x minus tan inverse 4 upon 5. Okay. So tan inverse x derivative is 1 upon 1 plus x square. Then tan inverse 4 upon 5 is a constant, and so derivative will be 0. Okay. Then next question is differentiate with respect to x. Here what is given? Tan inverse 5x upon 1 minus 6x square. Now I am writing this 5x as 3x plus 2x. Okay, so tan inverse 3x plus 2x upon 1 minus 3x into 2x. Okay, now this is exactly in the form of tan inverse x plus tan inverse y. Now I have to do the differentiation. So after finding derivative, what I will get? I will get dy upon dx as derivative of tan inverse 3x will be 1 upon 1 plus 3x square into derivative of 3x, and derivative of 3x will be 3. So finally I will get 3 upon 1 plus 9x square. Then derivative of tan inverse 2x will be 1 upon 1 plus 2x whole square into derivative of 2x, and derivative of 2x is 2. So finally what I am getting? I am getting 2 upon 1 plus 4x square. So this is the required derivative. Okay. So with this I am concluding this video. Okay, in this video we had seen the derivative of inverse trigonometric function. Thank you students.